In the example 10.4, we want to find the least squares parabola for the 4 points. And we want to use the least squares parabola to approximate y at the point where x equals 4.5. Let's see that we have 4 points altogether. So in this case, n is 4. N is 4. And the table, if you want to get the table for the points, the given point, when s is negative 3, y is 3. When s is 0, y is 1. When s is 2, y is 1. And when s is 4, y is 3. Okay. And we want to get a quadratic or a parabola by using the technique of least square. That means we want to minimize the summation of error square. So the system of normal equations will be the same as in example 10.3. Okay. In example 10.3, the system, this one. You still remember the coefficient matrix? I can write that down for you. Okay. System of normal equations. Matrix will be of the size 3 by 3, the coefficient matrix. And the variables that we are finding are a, b, and c. Actually, your polynomial, second degree polynomial, your px that you are finding is a plus bx plus cx to the second, and you will be solving the system of normal equation to find out a, b, and c, the coefficients of your second degree polynomial. So out of your coefficient matrix, I'm going to make it a little bit bigger. N goes there. In this case, n is 4 because there are 4 data points. And the next spot is summation xi. I run from 1 to 4. I'm not sure if I have enough space, so let me move this a bit to the right. Make my matrix a little bit bigger. And then summation of xi squared when I run from 1 to 4. Okay. And then at that spot, it's going to be summation xi. I run from 1 to 4. And then you can just copy this. The element in the second row, second column is that. It's just like you shift to the left of one spot. And then that's going to be summation siq. I run from 1 to 4. Okay. I need a little more space to write the last row of my matrix. So that is summation si squared, summation of siq, summation of si to the power 4. And you add summation of si squared from 1 to 4, summation of si cubed from 1 to 4, and summation of si to the power 4 from 1 to 4 because there are 4 data points. And the right hand side is summation of yi. Again, I runs from 1 to 4. The next spot is summation of the product of si and yi. Again, I runs from 1 to 4. And the last spot is going to be the summation of si squared and yi. And I runs from 1 to 4. So you have to use the information in the table to get all those things that you need in the coefficient matrix, and also the constant terms. There are 3 of them on the right hand side of your system of normal equations. It'd be better if you use Microsoft Excel to construct a table to find the sum of each spot. Okay, I'm not sure if I have put that down somewhere. Oh, I didn't even put that. But it's just 4 points. So let me copy that. I thought I put it somewhere in the material already. So with the table, you're going to have let me put si as my first column. And then yi is my second column. I need si squared. I need si cubed. I need si to the power 4. I need si yi and si squared times yi. I thought that I put it already, but never mind. All the SI, I put them down. The SI are negative 3, 0, 2, and 4, and the YI are 3, 1, 1, 3. And then you square all the SI. Get 9, you get 0, you get 4, you get 16. You cube all the SI, and you get negative 27, 0, 8, 64. And you take the power 4 of each of SI to get 81, 0, 16 to 56. In the next column, you multiply SI and YI together, so you get negative 9 in spot, 0 in spot, 2, and 12. And in the last column, you multiply this column and that column together, SI squared and YI, and you get 27, you get 0, you get 4, and you get 48. And in the last row, in the bottom row, I'm gonna find the sum. Okay, I'm gonna write the sum with different color. So the sum of the SI is 3. You just add this column together, and the sum of YI is 8. Sum of SI squared is 29. The sum of SI cubed is 45. The sum of SI to the power 4 is 353. And the sum of SI times YI is 5. The sum of SI squared times YI is 79. Now you get the coefficient matrix and also the right hand side vector. So the system of normal equations to be solved is this system. So your system, N is 4, summation SI is 3, and then summation of SI squared is 29, so 3, 29, and summation of SI cubed, which is 45, 29, 45, summation of SI to the power 4 is 353. That coefficient matrix is multiplied by the vector A, B, and C that we are finding. The vector A, B, and C, that are the coefficients of the second degree polynomial we are finding. And the right hand side term has summation of YI, which is 8, summation of SI which is 5, and summation of SI squared times YI, which is 79. You need to solve this system. And I said earlier that if you do this in the test, in the final examination, you have to show in details how to solve this system by using Gaussian elimination. So I'm going to show you just like the way that you are supposed to do when you do your final examination. Write the augmented matrix and then reduce it down to by using Gauss elimination. Separate with a vertical line and 8, 5, 79. I'm going to create the leading one by dividing the first row by 4. Divide the first row by 4. Then my first row will be changed to 1, 3 over 4, 29 over 4, and then 2. The other two rows remains the same. I show you all the detail because I don't want you to take it wrong by thinking that you can just write in the system of linear equations and say, hey, this is your answer without showing the work. So when you do your test, you have to show the work in detail how to solve this system. And then after I've got the leading one, I perform 2 more row operations, say R2 minus 3R1 and R3 minus 29R1 to get it off those 2 spots. And my resulting matrix will be this guy, 1, 3 over 4, 29 over 4, 2. Last spot is 0, 107 over 4, 93 over 4. That is 93. 93 over 4, and that spot is negative 1. So this spot is 0, 93 over 4, 571 over 4, and that is 21. Okay, you have got rid of those two spots. The next row operation that I will be performing is multiply the second row by 4 over 107 to get the leading one in the second row, second column. So I multiply the second row by 4 over 107. Then my resultant matrix, the first row remains the same. That is 29 over 4. And the second row will be changed to 0, 1, and 93 over, because 4 and 4 will be cancelled. So 93 over 107 to negative 121. The last row remains the same. Okay, and I can then use this to get rid of those two guys. Okay, so I perform 2 more row operations in the next step, and the 2 row operations are R1 minus 3 over 4 R2. Just use this element, this pivot element, to get rid of everything else in that column. And then I perform R3 minus 93 over 4 R2. Then my resulting matrix, let me copy, because the changes will go to the first and the third row. The second row will remain the same. So I'll just erase those 3 spots in the first row. So the elements on those spots will be changed. And the changes are, so this is going to be 0, and then 706 over 107 to 17 over 107. And in that row you get 131112 over 107. And in that spot, oh, hold on, I put in the wrong spot. That's supposed to be here, because when I perform this row operation, I'm gonna get 0 in that spot, and this spot is going to be 2340 over 107. So we are almost there. In the next step, I'm going to multiply the third row by the reciprocal of this to create a leading one, and then use the leading one to get rid of everything else in that column. So I'm going to multiply the third row by 107, divide by 131112. So my resultant matrix, only the third row will be changed. The first 2 rows remain the same as in previous step. Then this is going to be a constant 1. And that spot will be changed to 585 divided by 3278. And you use this pivot element to get rid of those 2 guys in the third column by performing R1 minus 706 over 107 R3, and then performing R2 minus 93 over 107 times R3. And then your resultant matrix, the first 2 rows will be changed. So I copy that down. And this spot will be 0, this spot will be 0. Those 2 spots will be changed. Okay, this will be 0, 0, and you are going to get, I'm going to convert everything to decimal numbers. Okay, when you do your test, you just try to, you have to read the instruction very carefully. I can ask everybody to round it up to, let's say, 4 digits after the decimal point, or I can even ask you to follow the number of significant figures as what we did in the midterm test. So over here I rounded everything up to 4 digits after the decimal point. and I get my C as 0.1785. So those are the value of A, B, and C that we are looking for. After you've got A, B, and C, then you get the quadratic regression. So your P of X that you are finding, and you can use it to approximate the data points in such a way that the summation of the square of the error is minimum with the least square technique. It's A plus BX plus CX squared. And you just put your A, your B, and your C right down. Your A is 0.8505. Your B is negative 0.1925. And your C is plus 0.1785 x to the second. So that is the look of second degree polynomial or parabola with the technique of least square. But the question asks us to find what? To approximate y at s equals 4.5. So you have one more thing that we have to do. I want to approximate. So p at s equals 4.5. You just plug x as 4.5 and then evaluate the approximation. So 0.8505 minus excuse me, 1925 times 4.5, and then 0.1785 times 4.5 square, and evaluate that out to get the approximate value of 3.5989, and that is the answer to the question. Don't forget that when you do this in the exam, if you happen to have a system of normal equations, you have to show me the detail of the work, how to solve the system for the constant A, B, and C.